Welcome to today's lesson. Today we want to learn about the surface area of prisms. But before we continue, let us remind ourselves of what we learned in our last lesson. In our last lesson, we looked at the area of a sector. We learned how to determine the area of a sector. And we understood that a sector is formed by dividing a circle with two radii. So we said a sector has an angle inside it. And we said for this area to be calculated, you're supposed to know the angle inside the sector. Then you multiply by pi r squared. Because we said a sector is a fraction of a circle. And the fraction of a circle is determined by the angle of one revolution of a circle, which is 360 degrees. So that was how to determine or to calculate the area of a sector. Now let's move on to today's lesson. And today we want to learn about the surface area. Remember that we are including or introducing a new term or adding another word to area. We have been looking at the areas of different shapes, but now we want to look at the surface area. What's the difference between just area and the surface area? So we'll learn as we move on. And what is a prism? Because we are going to look at the surface area of the prism. Before we look at how to determine the surface area of a prism, let us try to understand this term, prism. What is a prism? That is definition. A prism is a polyhedron with constant cross-section. It's a polyhedron with a uniform cross-section, meaning it has many surfaces, but then it also has what we call a cross-section. What is a cross-section? A cross-section is the shape that is at the ends, the both ends of a prism is what we call the cross-section. For example, let's look at this solid. Now we are dealing with three-dimensional objects. For us to be able to talk about a prism, it must be a three-dimensional object, meaning it has the length, the width, and the height. So let us look at this object. It is three-dimensional. We will look at, you realize that it has the surface. This is what we call the cross-section. And the cross-section, you realize that they are identical. There are two identical ends. There is this end, and there's the other end of this object. We have this end, and we have the other end also. The ends of a prism are normally identical. They are normally equal. They are normally congruent. Ends of a prism are congruent. They are identical. They are equal. Then these other parts that are in between the ends are either rectangles or parallelograms. These ends, these are the sides of a prism, are either made up of rectangles or parallelograms. We said in our last lesson that a parallelogram is a tilted rectangle. So all of them will appear four-sided figures. So it is the cross-section. So cross-section of the prism will give the name of that prism. The cross-section of a prism will give the name of that prism. For example, I've said this is the cross-section. That is the cross-section, the end of the prism. The cross-section will give us the type of the prism and the name of the prism. For example, this one, the cross-section is a triangle. The cross-section is a triangle. Then the name of this prism will be called triangular prism. Triangular prism. It has three sides. It has three sides. So we have said by looking at the cross-section, it will give us the name and the type of the prism. Let's look at another one. This is also another prism that has the cross-section, and it has these sides, the other sides also. So we look at the cross-section, and the cross-section will give us the type of the prism. This is the cross-section. If you look at the cross-section, this side and this side are equal, meaning this is a square. This is a square. So because this is a square, we call it a square prism or a cube. A square prism or a cube. What do you call this type of a prism? We said we look at the cross-section, and the cross-section is a rectangle. We are not told that these are equal. We are not told that the sides are equal, meaning this is a rectangle. So because the cross-section is a rectangle, then we call this a rectangular prism. One other characteristic of a prism is that the cross-section of the prism is always parallel to the two identical or congruent ends. The other sides of a prism are parallelogram or rectangles or right prisms. What do we mean by right prisms? If it here is 90 degrees, if the angles are 90 degrees, then we call this a right prism. But if they are parallelograms, then this is not a right prism. A right prism, we have said, the angles are 90 degrees. That means this other side of the prism are rectangles or squares that will make a right prism. So what then is the surface area? Because we want to understand or determine the surface area of objects, so we are trying to understand the terms before we calculate. What is surface area? Surface area of a prism is the sum of all the areas, or sum of all the areas of its faces. We have said that a prism has different or many faces. This is one face, this is another face, this is another face, this is the other, we have at the bottom another face, and the other side another face. So all these faces, if we calculate their different areas and add them together, what we will get is the surface area. Surface area is the sum of the areas of all its faces. How do we determine the surface area of a prism? One method is breaking down, opening up the solid so that we have a two-dimensional figure from a three-dimensional figure. Remember what we have just drawn. The prism is a three-dimensional object. It has the length, the base, and the height. That's a three-dimensional figure. But we can open up the prism so that it has different faces which are two-dimensional. We call that one a net. If we open up the faces of a prism, we'll have faces which are two-dimensional, and that will give us a net. So one method of calculating the surface area, we have said the surface area is the areas of all the faces, then adding them together. We're saying you can open it so that it becomes a net. We have said a net means you have two-dimensional surfaces or faces, and then you can be able to find, for example, let's look at this solid here. This is, if you can look at it keenly, you realize which type of a prism is this one? It has one end is triangular, meaning it's a triangular prism. So let us open, and we will open from this end. Let us open this prism. If we open, you realize that we'll have this side, this top side will come here, then we'll have the other side coming here, and the bottom will be here. Then the bottom will carry this side and the other end. These ends have the shape of a triangle. They have the shape of a triangle. So the most important thing when you are opening up a prism is to be able to open up correctly and be able to draw the net correctly so that you can be able to get the right surface area. When you open up this way, you will find that this is a rectangle. A rectangle normally has a length. It also has a base. So if you calculate the area of this rectangle here, you will get LB. That is the area of the rectangle. The same case with this other side. This is also a rectangle. So to calculate the area of this rectangle, you calculate by length times base. This is also another rectangle. You also calculate it, length times base. Then we have a triangle. So you find the area of this triangle. And how do you find the area of a triangle? Half base times height. That means you're supposed to know the height. You also find the area of that triangle. Then now we can be able to add all the areas of the different faces together, and we'll have the surface area of this solid. So if we open this way, then we call this the net of a solid. The net of a solid. Dimensions are very important as you open, as you draw, so that you don't change the dimensions. If they are 8 centimeters, they should remain 8 centimeters. So you realize that if we open the net, if you open the solid, and we have its net, because this is the net of this solid, the net of the triangular prism, then you realize we come up with what we call a composite figure. We come up with a composite figure. And in our last lesson, we looked at how to calculate the area of our composite figures. And we said we calculate the area of different faces and add them together or subtract, depending on the type of the figure. But on this, like this prism, we add the areas of different faces. The other way of calculating the area or the surface area of the prism is we can calculate the area of the prism without having necessarily to open up the prism into a net. In other words, we can take an example. So we are given a prism and we have these dashes to show that this side and this side and this side are equal. And we have said we determine the type of the prism by looking at the end, the shape of the end, and this is a square, meaning this is a square prism or a cube. We are told to find the surface area, and we said we calculate the surface area by adding areas of different faces together. So the first thing that we need to do is to know how many faces are in this solid. How many faces are there? So because this is a cube, it means all sides are equal. The only thing we need to know are how many sides there are. So let's look at the number of sides or the number of faces that we have. We have the first one, this one. We have the other side, the other end, 2. We have the top, 3. The bottom, they become 4. We have this other side. This other side, this other face, that becomes 5. And we have the last, the face that we are not able to see. So a cube has how many faces? 6. And we are told all the faces are equal. So what do? We calculate the area of one face, multiply by 6. How do you calculate the area of a square? In our last lesson we said length squared. So one face of the cube has 4 square centimeters. Because there are 6, we have just realized that there are 6. We multiply by 6, and that will give us 24 square centimeters. This is the surface area of a cube. So this is, we are multiplying by 6 because it is a cube and all sides are equal. What if all sides are not equal? Like a rectangular prism. Find the surface area of this prism. You realize that this is a rectangular prism because one end, the two identical ends are rectangles. So how do you go about it? We're saying we will identify all the different faces, find their different areas, and then sum them together to give us the surface area. So let's look at the faces, the number of faces that are there. So we have this bottom face, which is made up of this rectangle, measuring 1 centimeter by 2 centimeter. Area of a rectangle is length times base. So we say 1 centimeter, and that will give us 2 square centimeters. This is the area of this face here. And because this is a rectangular prism, the bottom, we have calculated this one, the bottom side. The bottom side is the same as the top side. Those faces are equal. So if they are equal, we multiply by 2 to cover the top face and the bottom face. That will give us 4 square centimeters. So we are done with the top and the bottom. Let's look at this side, this end. This end is made up of a rectangular face measuring 1 centimeter still by 3. Again, because there are two, this end and the other end, they are identical, we multiply by 2. And that will give us 6 square centimeters. So we are done with this side and the other end. We have this other face that is measuring 2 centimeters by 3 centimeters. What is the area? Again, because it has 2 identical faces, this one and this one, we multiply by 2. So now, we have the 3, we have the 3, because we have multiplied it by 2, there are 6 sides, there are 6 faces. But because we have done them 2 by 2, we now have the areas of the 3 faces. We will add them together. And that will give us 22 square centimeters. That is the surface area of this rectangular prism. You must calculate the area of each face. Remember to capture the area of each face. Let's look at this other type of prism. And we said if you look at this end, this cross section, you realize it is a triangle. Then what then do we call this type of a prism? It is a triangular prism. So it's a triangular prism. We are told to calculate the surface area of this prism. How do we go about it? So again, identify the type and the number of faces that make up the prism. So we realize we have two triangles, this one and at the other end. We have rectangles also. We have rectangles here, this side, and this side, bottom. So how many rectangles do we have? How many rectangles do we have? Let's start by calculating the area of the rectangles. So we know from our last lessons that the area of a triangle is half base times height. So what is the base of this triangle? We want to calculate this triangle. What is the base? You realize it is 6. And our height, the height is normally the perpendicular height, 90 degrees with the base. Our height is 4. And because there are two, remember, most cases in the prism, it has two identical ends. We multiply by 2. 2 cancels with 2. We have 24 square millimeters, the area of the triangles. And then now, let's look and calculate the area of the rectangles. We are done with the area of triangles. We now calculate the areas of the rectangles. So we have the bottom rectangle that is measuring 6 millimeters by 6 millimeters. This makes a square. So 6 millimeters by 6. Area of a rectangle is length times base. And in this case, it is a square, so that means it is length times, or length squared. So that will give us 36 square millimeters. So that will give us 36 square millimeters. Now, how many faces are remaining? So we have 2 more faces remaining, that is measuring 6 millimeters by 5 millimeters. 6 millimeters by 5 millimeters. This side and this side. That is a rectangle. Six millimeters by 6 times 5, that will give us 30 millimeters. So then we can now add the areas of the different faces together, and that will give us the surface area of this prism. And that is 24 plus 36 plus 30. That will give us 90 square millimeters. 90 square millimeters. let's look at another example. So this is an example, another example, an open box. That is, the box does not have a lid. In the shape of a cube is made of wood that is 2 centimeters thick. Its outside length is 40 centimeters. Find the surface area of both inside and out. So we know that the surface area is the surface area of all the faces, is the area of all the faces. Then you add them together. So this is a cube, meaning all faces are equal. So let's start by calculating the area of the cross-section. So that will be 40 times 40. And this, because all sides are equal, all faces are equal, the outside. We are now starting to calculate from outside. We have this side, that side, that is 3. We have 4, we have 5. So this cube, because the outside, this upper side is open, then we are not going to add. That means if we calculate one face, we multiply by 5. Because all the faces are equal. If we multiply by 5, that will give us, this is and that is in centimeters, square centimeters. Then this is the surface area of all the outside faces of the cube. Now, what about this other top? The top side is open, but it has a hood that has a thickness of 2 centimeters. So if we connect, you realize here this side will form a rectangle. If we introduce the dots, this will form a rectangle that is measuring 40 by 2. So for us to be able to calculate the surface of this top, we say 2 times 40. It is the same case here also, because thickness is 2 and the length is 40. Remember, this is a cube. Then this is also 2 times 40. We'll have been able to calculate the area of that. For us to calculate the area of this side, you'll also realize that this is 2 centimeters and this is 40. So again, it is 2 times 40. Same case with this side. 2 thickness, which makes the width or the base, times the length, which is 40. So that means we say 2 times 40, and we have 4 small rectangles. So 2 times 40 times 4, that will give us 320. We can add as we move on. Then now we have, the box is open inside. The box is open inside. If we can but now it is open, we have the surface inside, because we are told to calculate the surface area both inside and out. So you realize that inside, if we look at the dots, you realize that inside it will be less here by 2 and will be less by 2 on this other side. So it's supposed to be 40, but because of the thickness of the wood, it will be less by 2 centimeters on this other end and 2 centimeters on the other end. So that will leave us with 40 minus 4, that will be 36 centimeters. We are trying to find the values of the surfaces or the dimensions of the surfaces inside the box. So because this is a cube, it means it will be the same all round. So that means inside we have 36 by 36. How many surfaces do we have inside? You realize we have this side, the end, and bottom, again times 5. So if we calculate, so the total surface area, 15,800 square centimeters. So we are able to calculate all the area of the surfaces, and then we add them together, and that will give us the total surface area of that particular prism or a solid. We have said that a prism is a 3-dimensional object. So for you to be able to get the surface area, you add all the surfaces, all the areas of the surfaces, and you will get the surface area. The next thing that I want us to look at today volume and capacity. Let us now look at volume and capacity. Here we are still talking about three-dimensional objects, meaning it is not two-dimensional. We are not talking about two-dimensional figures. We are talking about three-dimensional objects, which has the base, the length, and the width. So what is volume? Volume is the measure of space occupied by a three-dimensional object. That is volume. It is measured in cubic meters. Measured in cubic units, sorry. Measured in cubic units. What do we mean by cubic units? We know that length is measured using a meter. And the common units we have are millimeters, the common units that we normally use to measure length is millimeters, centimeters, meters, and kilometers. We said that when you are measuring area, we use square units, meaning you multiply the unit by itself. For volume, we use cubic units, meaning we multiply the unit by itself 3 times. Why is it so? Let's take an example. Let's take an example of a cube that is measuring 1 millimeter by 1 millimeter by 1 millimeter. This is a three-dimensional object. It has a length, base, and a height. We said in our in the other lesson, when we are looking at length, that 1 centimeter is equals to 10 millimeters. 1 centimeter is equals to 10 millimeters. So we have 1 millimeter, that is the length, and the base is 1 millimeter, and the height is 1 millimeter. For us to be able to get the volume of the cube, we calculate we say length times base times the height. The formula for calculating the volume of this cube is length times base times the height. If this is the case, length times base times the height, and our measurement is 1 by 1 by 1 millimeter, then we can substitute in our formula, and we have 1 millimeter. What then do we have? 1 cubic millimeter. We'll come up with 1 cubic millimeter. So that's why we are saying volume is measured in cubic units. Supposing it was, the measurement was in centimeters, then volume would be 1 centimeter times 1 centimeter times 1 centimeter. You realize we are multiplying centimeter by itself 3 times. What do we have? 1 cubic centimeters. Same case with meters. If it is 1 meter, that will give us 1 cubic meter. 1 cubic meter. Now let's understand how to convert. Let's learn how to convert from millimeters, 1 unit to the other, millimeters to centimeters to meters, and finally to kilometers. We know that kilometers is our larger unit here, followed by meters, centimeters, and then millimeters, that is in cubic form. So if we are changing in our last class, the last class that we have learned, that if you are coming from a larger unit to a smaller unit, you multiply. You multiply. So if you are changing from kilometers to meters, you multiply. And let us go back to our length and see how many meters are in 1 kilometer. You realize that we said 1 kilometer has 1,000 meters. We said that 1 kilometer has 1,000 meters, 1 meter has 100 centimeters, and 1 centimeter has 10 millimeters. Now, for us here, we said cubic kilometers means you've multiplied the kilometer by itself how many times? 3 times. So this is 1 kilometer times 1 kilometer times 1 kilometer. Now, if we are supposed to change into meters, and we are saying in 1 kilometer we have how many meters? 1,000. So that means, and this will give us 1 cubic kilometers. So that means in 1 cubic kilometer, let us find out how many meters are inside. So for 1 kilometer, we have how many meters? 1,000. Then so how many meters do we have in 1 cubic kilometer? You realize there are so many, we have so many zeros here. So we can just write this way. Instead of writing all the zeros, we put, because 1,000 is multiplied by itself 3 times. So we can say 1,000 cubed. That is meters, which is equal to 1 kilometer. 1 cubic kilometer. So in 1 cubic kilometer, how many meters do we have? 1,000 raised to power 3 meters. That is kilometers. So that means if we are supposed to change from kilometers to meters, we are supposed to multiply by. So to multiply, to change from cubic kilometers to cubic meters, then we multiply by 1,000 cubed. Let's see. So if we are supposed to move from cubic meters to cubic kilometers, what are we supposed to do? Because we are moving from a smaller unit to a larger unit. And from our last lessons, we said if you are moving from a smaller unit to a larger unit, what do? You divide. So you'll divide by the same value. Let's go back to our length again and see how we arrive, or the value that we get, how to get what to use to convert from meters to centimeters. From our length, the units of length, 1 meter has 100 centimeters. Now for us, for a cubic meter, we say and that will give us 1 cubic meter. 1 meter has 100 centimeters. So if we multiply this, you realize again one cubic meter is equals to 1 million cubic centimeters. So if you are changing from meters or cubic meters to centimeters to cubic centimeters, you multiply. You multiply and you multiply by 1 million. If you are converting from square centimeters, from cubic centimeters to cubic meters, you will then divide by 1 million. What about centimeters or cubic centimeters to cubic meters? We know that 1 centimeter in length, in the unit of length, contains 10 millimeters. If we are using cubic units, then one centimeter times 1 centimeter times 1 centimeter, that will be equal to 1 cubic centimeter. In 1 centimeter from the units of length, there are 10 millimeters. So if we multiply, for 1 centimeter, we have 10 millimeters. 1 other centimeter is 10 millimeters. 1 centimeter gives us 10 millimeters again. So if we multiply, we get 1,000 cubic millimeter, and that is equal to 1 cubic centimeter. So if we are converting from cubic centimeters to cubic millimeters, we multiply. We multiply by 1,000. If we are converting millimeters or cubic millimeters to cubic centimeters, then we divide by 1,000. Divide by 1,000. We also have, this is volume, and the units of volume, cubic units. We also have, remember our topic is volume and capacity. We also have capacity. Let's look at the definition of capacity. And that is, capacity is the volume of a fluid or gas. The volume of a fluid or gas. Volume of a fluid or gas that a container can hold. That is capacity. Capacity is measured using the following metric units. Milliliter. This is different from millimeters, and it's written in short as ml. So the units that we use to measure capacity is milliliters, liters, kiloliter, and megaliter. Let us understand, again, if we are supposed to convert from one unit to the other, how do we go about it? So 1 milliliter is equal to 1 cubic centimeter. Remember, we have talked of cubic centimeters in volume. So we are saying if you have 1 milliliter in capacity, it is equal to 1 cubic centimeters. And 1 liter is the same as 1,000 cubic centimeters. 1 kiloliter is equal to 1,000 liters. 1,000 liters, that means, and 1 liter is equal to 1,000 cubic centimeters. So if you want to get 1 kiloliter, then you multiply by 1,000, you will get 1,000 cubic, 1 million cubic centimeters. So these are the metric units that are used in capacity. Let's take some examples. We have a rectangular prism. We are told to find the volume of this prism. What is the formula of calculating the volume of a prism? Volume of a prism, of a rectangular prism, is got by multiplying the length times the base times the height. A rectangular prism, volume is length times the base times the height, which in our case, if we replace the units or the dimensions of this prism in our formula, then we have 4, which is the length, times 6, the base, and then 2, height. This will give us 48 cubic meters. 48 cubic meters. So remember to put units in cubic units, cubic units. Which type of prism is this? You realize that all sides are equal. That means it is a cube. A cube has all the faces equal and all the sides equal. So how do you find the volume of a cube? We say side cubed or length cubed. If we substitute the values in the formula, we have so 4 times 4, we have 16 times 4, that will give us 64 cubic centimeters. That is 64 cubic centimeters. So to be able to calculate the volume of a cube, this is the formula, length cubed or side cubed. Let's look at an example of how to calculate the capacity. We are told to find the capacity in liters for a container that is a rectangular prism, 20 centimeters long, 10 centimeters wide, and 15 centimeters high. So for you to be able to calculate the volume of that prism, you can represent it by drawing So again, we have said to calculate the volume of the rectangular prism, we say length times base times the height. So our length is 20, our base is 10, and our height is 15. So we multiply 20 times 10 times 15, and that will give us 3,000 cubic centimeters. That is 3,000 cubic centimeters. We are told to calculate the capacity, and we have defined capacity to mean the volume of a fluid or a gas that a container can hold. The volume that can hold. So how do we get capacity? We get capacity by calculating the volume still, using the formula of the volume. Remember, we are told to give the answer in liters. We have it in cubic centimeters. What do we do? If you can remember what we just said, when you're trying to convert one unit to the other, we said 1 liter contains 1,000 cubic centimeters. So what do we do? Converting, because we are changing from a smaller unit to a bigger unit, we divide. 1 liter has 1,000 cubic centimeters. So the capacity of this container is 3 liters. In other words, it can hold 3 liters. So today we have learned about the surface, how to calculate the surface area of a prism. And we have looked at different ways of calculating the surface area of prism. We said that you can have a net, then calculate the different areas of different faces, then sum them together. And we have also went ahead to look at finding the volume and capacity. And we've said to find the volume of a cube, you multiply the side by itself 3 times, that is s cubed. And to find the volume of a rectangular prism, we calculate using the formula length times base times the height. And that marks the end of our lesson. Thank you.